morning students, welcome to today's session, and I hope every one of you understood what all we have seen in the last classes. And we have seen about the division of polynomial, division of one polynomial by the another polynomial. And I think every one of you understood that method, how to divide a polynomial by the another polynomial. And before PA1 examination, we have seen so many problems, that is factorization of the given expression by using the algebraic identities. And today we are going to see the same kind of problems. Some problems are there by using the algebraic identities. Right? In today's session we are going to see that kind of problems only. So let us begin today's session. So before going to that, let us recall what and all we have seen in the earlier classes. Right? So the topic is polynomial, and that is a general structure of the polynomial. So this is useful to check whether the given expression is a polynomial or not. So how can we check whether the given expression is a polynomial? Means by checking the power of the variables. If the power of the variables all are whole numbers, then that expression is said to be polynomial, otherwise not. Okay. And the degree of the polynomial is nothing but the highest power of the variable in a polynomial is known as degree of the polynomial, and 0 of a polynomial. So when a real number is said to be 0 of a polynomial, if you substitute the real number instead of the variable in the polynomial, then if the value of the polynomial becomes 0, then the particular real number is said to be 0 of the polynomial. Okay. And division algorithm, if we divide one polynomial by the another polynomial, so we will have quotient and also remainder. Okay, so that relationship can be defined by P of x equal to x minus a into q of x plus r of x. So here the P of x is nothing but the dividend, and x minus a is nothing but divisor, and q of x is a quotient polynomial, and r of x be the remainder polynomials. And remainder theorem. So what is the application of remainder theorem? We can find out the remainder without actual division. Okay, like to find the 0 of the polynomial. Okay, so that for that purpose only we have to use that remainder theorem. And the next one, factor theorem. So how can we use factor theorem in the given questions? That is, it is very useful to check whether the given expression is a factor of the given polynomial or not. Okay, for that purpose we have to use the factor theorem, right? And these are the standard algebraic identities. So for the first one, a plus b whole cube, and the second one, a minus b whole cube. And these two formulas already we have seen in the last classes, and we have factorized so many expressions by the help of these two identities. Right, and today we are going to see that another identity, that is a cube minus b cube. So it is also derived from this formula only. Okay, that is a cube minus b cube equal to a minus b into a square plus ab plus b square. So this formula derived from this one. Okay, and similarly from the first formula we can derive this one. Okay, so a cube plus b cube, right? That is, if you keep a cube plus b cube here itself, and then if you transpose these two terms into left hand side, we will get this term. Actually in the last class, that is before PA1 examination, in the very last class we have verified these two formulas, right? And I think you have seen through the video, that is verify x cube, instead of a b there will be x and y, that is x cube minus y cube equal to x minus y into x square plus xy plus y square. Okay, so in this formula, instead of a put x and instead of b put y, you will get that expression. We have verified already in the last class itself. Okay, so these are the two important formulas, and today we are going to see how to factorize the sums or in the type of these two formulas. Okay, and one more formula is available, that is x cube plus y cube plus z cube minus 3xyz equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Okay, so this is also one of the formula here, right? So using the last three formulas, so in today's class we are going to see how can you factorize the questions, the given expressions by using these three types of formulas. Okay, so come to the example now. So factorize 27 p cube minus 1 by 216 minus 9 by 2 p square plus 1 by 4p. Okay, so here that cube terms will be there here. Okay, that is p cube is there, so definitely it will be a cube term, right? So how can we factorize this, and what type of formula is related to that? Okay, so look at the formula. So a minus b whole cube equal to, so a cube minus 3a square b plus 3ab square minus b cube. So this formula only we are going to use to factorize the given expression. Why we have to use this formula? Okay, so this expression is nothing but in the form of the right hand side of the formula. That is, this actually here we need two cube terms. So this is one of the cube term, and similarly from the other three terms, so which one cube term means? Definitely this one only, because 216 is the cubic number. We can write that 216 with the power of 3 with a number, but these two numbers not possible. So this one corresponds to a cube and this one corresponds to b cube. Okay, right? So this number corresponds to this one and this number corresponds to this one, and remaining two terms are for these two terms. Okay, so right, so how can you find a first now, right? So this one is corresponds to a value. So how can we write 27 with the power of 3 here? That is 3 cube. If you take power 3 to the number 3, it will give 27. That is 3 3s are 9, 9 3s are 27. So it can be written as 3 cube into p cube. Okay, and minus 1 divided by 260 is nothing but 6 cube. If you multiply 6 3 times, you will get 216. Okay, and then minus 9 by 2 p square, then plus 1 by 4 p. Okay, so here both of the factors having the same power, so we can take as a common power. So 3p whole cube and minus 1 divided by 6 whole cube, that is it will stand for a cube minus b cube. So remaining three terms are there, remaining two terms are there. How can we write this? So minus, so 3 into, so instead of a we can write 3p, so 3p whole square into b is there, right? Into b is nothing but 1 by 6. Okay, and plus 3ab square is there, so 3 instead of a again 3p and then b square, so b is nothing but 1 by 6, right? Now these two terms already there, the first term and second term, and if you simplify this means what will happen here? So 3p whole cube and minus 1 by 6 whole cube and minus, so 3 into, now apply the square here, so 3 squares are 9 and p is also there, so 9 p square into 1 by 6, right? And then plus here 3 into, or 3 into 3p into 1 by 6. Okay, so here actually here 3ab square is here, so 3ab square we can put square here as it is the formula. Okay, so here if you put square means it will become what happened? So 3 3s are 36, right? So 6 6 are 36 here, so the 2 will not come here. Okay, so the 2 will not come here, right? Now if you simplify this means what will happen? So this one equal to 27p cube and this one equal to 1 by 216, and if you simplify this means what will happen here, 1 3s are 3 and 2 3s are 6, and if you simplify this means 9 p square by 2 or 9 by 2 p square. So 9 by 2 p square is nothing but this term 9 by 2 p square, and then this one, so here 36 is there, so here 1 3s are 3 and 12 3s are 36, again here 1 3s are 3 and 4 3s are 12. What about the remaining one here? So p and also 4. So p divided by 4. So p divided by 4 is here. Okay, so we got the same term. How we got the same term here? By substituting instead of a 3p and instead of b 1 by 6. So how can we return now this one? So 3p minus 1 by 6 whole cube. Okay, so this is nothing but in the form of the left hand side expression, because the given term is nothing but right hand side expression. So we have converted this now into left hand side expression. So here power 3 is there, so we can write it with 3 factors here, that is 3p minus 1 by 6 again into 3p minus 1 by 6, so again into 3p minus 1 by 6. Right? So these are the factorization of the given question. Right? Look at the next example. So factorize each of the following. So 27y cube plus 125z cube, and similarly here also. How can you factorize this one? So let us see one by one. So 27y cube plus 125z cube. Okay. So this is nothing but only two terms are there and both having cubes. Okay. So it is in the form of a cube plus b cube equal to a plus b into a square minus ab plus b square formula. Okay, so when we compare this means, so this term a and this term b. How can we write 27 in the form of power 3 only? So 3y is there and whole to the power 3. So we can write 27y cube as 3y whole cube, and plus, how can we write 25 in with the power of 3 here? 5 power 3. So we can write 5z whole to the power 3. Okay, so now a is nothing but 3y and b is nothing but 5z. So the given expression is nothing but into the form of left hand side of the formula. So we are going to write this into right hand side format, that is, so here. Okay, so instead of a 3y, then here plus is there, so plus inside of b 5z, so 5z again bracket instead of a square 3y whole square and minus instead of a 3y and instead of b 5z and plus inside of b again 5z whole square. Okay, so equal to, so this is 3y plus 5z into, so now apply the square here. If you apply the square means 3 square 9 and y square is nothing but y square, and minus multiply these two, 5 3s are 15 and y into z, y is z, and plus if you apply the square for 5 and z, what will happen? So 25 z square. So 25 z square, right? So it is not possible to simplify again. So these are the factorization of the first one. Okay, and second solution also there. So let us continue the solution in the next video.